Hello students, welcome to the interesting chemistry where you will find a classroom teaching experience. If you want to enjoy a classroom teaching, then please watch my video of interesting chemistry. Today, in continuation of the classification of elements, it's my third video in which I have continuing with the modern periodic table and the electronic configuration. But before starting this video, I want to acknowledge you with my different videos which I have uploaded for you. So these are the list of the uploaded video. One is first the language of chemistry, in which I have explained the formulation and the balancing of chemical equation. Those students who have difficulty in writing the chemical equation, or they have to cram or mugging up the chemical equation, they should watch this video. I think they will get understood by watching this video, and they will 80% of the chemical equation they will write by understanding. They need not to cram or mug up the chemical equation. So please watch. Second one is IUPAC. I have made up different videos, 10 to 12 videos, particular for each topic, for each compound, alkane, alkene, you will find the different videos for alkane, alkene and alkynes, and also for the functional group. So please, if you are acknowledged with the name of any compound, or the structure of the compound, it means you are affiliated with that compound, and it will help to understand the properties and preparation of that compound. So please also watch this IUPAC. Third one is oxidation reduction, in which I have the redox reaction, what are the redox reactions, and also uploaded the balancing of the ionic equation. The balancing of the ionic equation is especially students found very difficulty in balancing the ionic equation. So on my experience, I have explained how will you balance the ionic equation. Next, above principle, in which the above principle that explains us the filling of orbitals. So the above principle also tells us that which orbital will be filled first. So this electronic configuration, to write any electronic configuration of any element, you should go through, you should know about the above principle. So I think that you have noted these all videos, and you should go through this video. And now I am going to start the third video of the modern periodic table and electronic configuration. So in my previous video, I have explained the electronic configuration up to 30th compound. I mean to say zinc. So it is the zinc, Zn30, and you will write here 2, 8, 18, 2, 8 and 18 and S2. So this 18, 20 and 30. These are the 30 electrons. This is the electronic configuration of the zinc. It is according to the cell, and when you will write here 1s2, 2s2, 2p6, 3s2, 3p6, 3d10 and 4s2. It is according to the subcell. It is according to the subcell. And if you write in this way, px, py, pz, px, py, z, it is according to the orbital configuration of the element. So this is it. So this electronic configuration, this is the electronic configuration of zinc. Now I will take the gallium. Here you don't know the number of gallium. Aluminum 30, it is 30, so you can add 1. So the number of gallium will be 31. I haven't written the number. Or in other way, this is this aluminium. So please walk from this step to the 30 to here and here. You will get the 18 steps. You have taken 18 steps. So add 18 into 13. You will find the atomic number of gallium. This is atomic number of gallium. Now you know that P is star. The filling of P starts here. So you will write here 4. This is 3. 4p1. So the gallium Ga31. Ga31 gallium, it means 2, 8, 18 and 4s2, 4p1. 4p1. It is 4p1. Now in the same 32, 31, 32, 33, 34, 35 and this is 36. So again the filling of the p orbital starts here. So gradually the p2, the germanium will be p2, arsenic will be p3, selenium p4, bromine and it will be p5 and krypton will be 6. So here I will write the bromine, which is the bromine 35. Bromine 35, how will we write? 2, 8, 18, 2, 8, 18, 4s2, 4p5. 4p5. These are the total number. 18, 28 and 5 to 7, 28 plus 7. Please check the total number. 28 plus 7, 35 to 4s2, 4p5. And this one, the krypton 36, that is the 36 to 8, 18 and 8. It is the krypton 36. 36. Now come to the here 37. It is 19 and you will add 18. Then it is rubidium. Rubidium, the atomic number of rubidium will be 37 and you can also write from here 36 to 37. So rubidium, this is also a way to write the electronic configuration. In this way you can write here 36 krypton. Krypton and you will write here S1 because the 37th electron will enter into the S1. Which S1? This is 6. Sorry, rubidium 37, the fifth S. So you will write here 5s1. It is the electronic configuration of rubidium. Then come to the barium, strontium 38. Then it will be strontium 38. You will write here krypton. Krypton 2, 8, 8, 18. This is krypton 36. So and 5s2. It is also a way to write the electronic configuration of this rubidium and cesium. Now again you come to the structure 57, sorry, 37, 38. You will come to 38. What is 38? That is scandium yttrium. This is yttrium, sorry, 38, 39. The atomic number of yttrium is 30. Scandium 21. You have to add 18 to find the atomic number of yttrium. So 21 plus 18 is equal to 39. 39. What will be the yttrium? So yttrium 39. You can write here 2, 8, 2, 8, and I am writing here 2, 8, 18, and here again 4s2, 4p6, and 5s2. 2, 8, 18, because again I am calculating, this is 36, 2, 8, 18, and 8. This is 36, and again the 5s2, 36, 5s and 5s2. So please relate to the previous electronic configuration. So it is yttrium 39. How will you write? So you have to yttrium, you have to decide the 39th electron, where will you go forward to? Because here 5s2, 5p is vacant, and here 4s2, 4p6, and 4d is also vacant. So you have to decide the 39th electron D. So again, as I told you in scandium, that the D1 will be infiltrated. So here the electron will enter into 4D and this 5B and 5B. How can you decide? In my previous video, I have explained you the 4D to find the value of n plus L. And 5p, find the value of n plus L. Those who are watching this video first time, I think they will find a difficulty to understand this video. So please watch my first video, second video, and above principle. Then you will get to know how will you write the electronic configuration. So 4D, the value 4D is 4D for n plus L, though n 4 and D is equal to 2. So here 6 and here 5p is here 5 plus 1. So here is also 6. So the value of 4D and 5p are equal. Then the second part of the n plus L, you will apply the second part of the n plus L. The second part says us, if the two or more orbitals have the similar n plus L value, it means they are equal in energy. So the entering electron will occupy that orbital which has the lower principal quantum number. So here the principal quantum number is 4. Here the principal quantum number is 5. So the newly entering electron, 39th electron, will enter into the 4. So this is 4d1. So I think that you have understood. Now I have again explained you the starting of D1. So here, as I told you, this is don't find D1, but it is n minus 1. It is n minus 1D. So here n is equal to 5, so D will be 4D1. Here for 40, it is 4D2. And now come to the niobium 41. Niobium, it is niobium 41. So again, I am telling you 2, 8, 18. 2, 8, 18, 18, 18, so here 40, so 2, 8, 18, here 8 plus, which one? Niobium 41, 39 for D3, and here 3 plus 1, 2, 3, 4, and 5s2. As I explained you, so in the yttrium zirconium and yttrium and zirconium, yttrium 39, I had it in 2, 8, 18, 4s2, 4p6, 4d1, and 5s2. It is 40. And yttrium, then come to the 40th one is zirconium. Then zirconium is 40. So you will write here 4d2 because one electron is added here, 39 and 40. So this d1 will be 42. In the same case, you will write here 2, 8, 18. In case of niobium, 2, 8, 18. And this one is 4s2, 4p6, 4d3, and 5s2. 4d3, 5s2. So here, please, I want to acknowledge you, I want to tell you, it is also a case of exception, as I told yesterday about the chromium and copper. It is again one electron will be migrated from here, and you will find the electronic configuration of chromium 4d4 and 5s1. 4d4 and 5s1. So here it is also a change in case of niobium, when because in your examination these the elements, those have the exceptions in the exceptional electronic configuration are asked. So niobium is also, you will, according to rule, it should be 4d3, but it is changed. One electron is migrated, then 4d4 and 5d. Now come to the zircon, niobium, then again chromium, this one molybdenum. Molybdenum, number of molybdenum 24 plus 18 is 42. Then right here molybdenum in the same manner, 2, 8, 18, 2, 8, 18, 4s2, 4p, this one is 6, and this 4d, I explained you 4d4. Now it will be 4d5 and 5s1. 5s1. This one is the 4d5. 5s1. It is similar to the chromium, as I told you. The d4 will be d5. One electron is migrated to the chromium. Now it is technetium. Technetium is 25, 18, 43. 43. So technetium 43 will be here 4d5. It is will remain, and this 5s will be 5s2. This as well. So this one the technician 43rd electron will be enter into the 5s2. Again come to this technician. Then ruthenium, again iron, ruthenium number 44. Ruthenium number 44. So again here the 44 you will write here 4d. Please note it. I am giving it is also exceptional. It should be 4, 6 and 5s2. According to the Rameau principle, the electronic configuration of ruthenium 44 should be 4d, 5 to 4d, 6 and 5s2, but not. Again one electron is migrated to here, and this you should know 4d7 and this one, sorry, 5s2. So you write here again 5s1. This one will be the electronic configuration of ruthenium 44. Again I am telling you, now come to the ruthenium. This one is rhodium. The rhodium number of rhodium, these are H 44 to 45. Then this one is 4d8 and 5s1. This is 4d8 and 5s1. This is the rhodium. Then come to the palladium. The palladium you will find a repeatedly. It is the palladium, the electronic configuration of palladium. This 28, 18, 46 palladium. The electronic configuration of palladium is asked your examination repeatedly. And here this palladium 41 electron is added here. So the 4d9, you will write here 4d9 and 5s1, but not. Now here it will be 4d10 and 5s0. This one electron is migrated and s will be vacant here. So the palladium 46 you will write here 2, 8, 18 and 18. 18 and 18, only 18 and 18. It is the electronic configuration of palladium. I take 10 and 36, 46. So please note it. It is also an exceptional case in the palladium. So this type of electronic configuration, the palladium. So the electronic configuration of palladium has been asked in your examinations repeatedly. So this is what. Now come to the again palladium. Now come the copper. This will be copper. Sorry, copper and silver. This is the silver. Ag silver, the electron is silver 47. 47. Again, you will write here the same 2, 8, 18. And this one is also 3, 4s2, 4p6, 4d10 and 5s1. 5s1. This is the electronic configuration of silver. Now come to the silver. This is silver, and cadmium it is 48, and this will be again 48 cadmium 48, and this will be 5s2. Again from the cadmium you will come to indium. This one is 48, 49. Then indium In 49 2 for the 5s2, and here the 5p1 will be open. here in the, because you came here 49, so 49 here P1, which one P1? 5 P1, P1 will be open here. So in this way the P1, P2, P3 and P4 xenon you will write here. Gradually the electron will be added into the P1 and P1 will be P6. So you will write here xenon. What the number of xenon? 54, and 54 you will write here 2, 8, 18, 18 and 8. It is the total 54. So please count this number. 18 is 36, 46 plus 8, 854. This is the genome. Now come to the structure here. Genome 48. This is 54, and this will be 37, 8. Cesium will be 55. Barium will be 56. And this is lanthanum. This is lanthanum. So I will tell you about this cesium, Ce55. You will write here the same 1, 2, 3, 4, 5 and 6, 1 will be here. Or you can write xenon 6, 1 and cesium, that's barium 56. This is barium Ba55 56. You will write here xenon 6s2. Xenon 6s2. This is in this way. It is lanthanum 57. So I will write here 2, 8, 18 and 4s2, 4p6, 4d10 and here 5s2, 5p6, 5d10 and here 5d6s2, 5d10. So here 18, 5, note 5, say 5s2 and 6s2. 6s2. This is the total 2, 8. This is 18 and this is 8 and this is 2. So the total will be 18, 18, 36, 10, 46, 8, 54 plus 2, 56. This is the electronic configuration of barium 56. Now, lanthanum, you have to decide about the entering of the 57th electron in lanthanum. So the possibilities are, there are 6p, here is 6p, here is 5d, and here is 4f. So there are 3 orbitals. Please try to understand. There are 3 orbitals. Which one? 4f, 5d and 6p. 4f, 5d and 6p. So decide in which orbital the 57th electron will go. So here 57th. So how will you calculate the 4f for the n plus l? The n plus l value of the 4f is equal to 4 plus 3 is equal to 7. For 5d, the l plus 5, the d, it is also 7, and this one 6p. So again 6p, the 6 plus 1. So all the 3 orbitals 4f, 5d and 6p have the similar value of n plus n. 7. Now decide in which. So I told you, you will apply here the second rule of n plus n, second part of n plus n rule, in which the electron will go in which that orbital which have the lower principal quantum number or lower value of n. So the value of lower, this is 6p, 5 and 4. With the Arbonium, with the Arbon principle, with the law of Arbon, the 57th electron must go in 4f. 4f. Try to understand. It is a special case, but it doesn't go into 4f. It goes to 5d1. 5d1. So the lanthanum is d1. It is n minus 1, n minus d1, n minus d1. So this is the an exception case for the lanthanum. I think that you have understood. So you will write here from the lanthanum d1, 5d1, and this f will be not entered. So you make it here. So this is the electronic configuration of lanthanum 57. This is the electronic configuration of lanthanum 57. Here, the 57th electron should have been gone to the 4f, but it enters into the 5d1. This is an exceptional case. From the 57, from here, lanthanum 57 to next with the 58th, you will not find here 58 happening. After lanthanum 57, after the cerium 58 to the lutetium 71, Lu 71, there are 14 elements. So this electronic configuration of cerium 58 after the lanthanum, that will be 2, 8, 18 and 4s2, 4p6, 4d10 and 4f1. Now the f will be started here, that I leave 4f1 and 5s2, 5p6, 5p6 and 5d1 and 6s2. This will be the start. Now there are 14 electrons. There are 14 elements from cerium to lutetium. So the spinning of the d orbital, 4d orbital, 4f orbital starts. So all the 14 electrons will be entered into 4f, which will be 4f14. So now come to this here hafnium, lanthanum and hafnium. This is the number of this hafnium will be 72 and so on. This is about the. Now come to the next in the same is actinium. I will tell you the example of the actinium. Now actinium, what is actinium? Before knowing the actinium, this is 57, 89. It is also an exceptional case, 89 actinium. So before writing the actinium, you should write the radon 86 Rn. 86. What is the 2, 8, 18, 32, 18 and 8. This is the 86. I think 50, 60 and 60, 80, 26. This electronic configuration of the radon. Now write this one. So the French of the radium. I am writing here the radium 86, 7 and 8. radium 88, 2, 8, 18, 32, 18, 8, 1, 2, 3, 4, 5, 6, and it will be 7s2. 7s2. It is 7s2. It is the total calculation of the mathematical number. So please try to understand. I think that this topic is very boring for you. I know it very well, but I am trying to make you understand. My hard work, I think that my hard work will be useful for you. If any two students will understand this electronic configuration, so I think that I have taught something to you. So here, in this way, I am telling you about the actinium. This is actinium 18. So, how will you write the electronic configuration of actinium? This is actinium AC 89. AC 89. So same electronic configuration you have to write up to here. All are filled well. 2, 8, 18, 32. Now here you will write 5s2, 5p6, 5d10, and here 6s2, 6p6, and here again 7s2. This is still I have completed the 88 electron. Now you have to decide that in which orbital the 89th electron will go. Now you have to try the 89th electron go. Here are also here 5d, 5f. Here is 6d. And here is 6p. So leave the p to decide whether the electron will go in 5f and 6d. So the value of you will calculate. So according to the above principle, the 89th electron should go in the 5f, but this not go. It will be 3,6d. It is also a exception in the above rule. Above principle. So again I am telling you that this. So this now after actinium there are 90 thorium, Th 92, lawrencium Lr 100 So this D will be start, 5D will be start, and 5D will the 14 electrons will be entered in the 12 to lawrencium. This is about the electronic configuration offered. So lanthanum 57, the 58th electron goes to cerium. The 58th electron goes to cerium. So after these 14 electrons are called as actinides. Lanthanum. After the lanthanum, the 14 elements after lanthanum are called lanthanide, and the 14 elements after the actinium are called actinides. These lanthanides and actinides are written under the periodic table. This is cerium 5840 and this is thorium 90 to 143. So I have explained you the all electronic configuration up to 103. I think that you have understood it. Please, I have done a very hard work to make you understand this whole electronic configuration. I think it is a game of mathematical calculation, 18, 20, plus, minus, and so on. So you have to count all the electrons in the particular cell. So please, if you will try well, if you will see my video regularly and repeatedly, so I think when the day will come that you will understand how to write the electronic configuration up to 104. So that's okay for today. Please share it, like it, my video. so that your other friend can also take help from this video. So for today, it's okay. Thank you.